Yeah, hello everyone. Assalamu alaikum. Welcome back. In this video, I want to briefly discuss about the current research trends, like the things that became very popular in the recent years. So one thing that became very popular was self-supervised learning. In a previous video, I explained how self-supervised learning works in a nutshell. So essentially, it's about leveraging unlabeled data where you create some artificial labels that you can use for supervised learning. But this is really for data sets where you don't have labels for your target tasks. So you would come up with tasks like separating an image into individual parts and then predicting the neighboring parts of an image. So if you have the face of the cat and then an ear, and you show the network only the face, the network should predict the prediction of ear, whether it's here the upper left corner, upper right corner, and so forth. And by that you teach the network to understand better the object structure of a cat, like what a cat looks like. Another hot topic is contrastive learning. So this is a form of self-supervised learning where you generate two versions of an image. So let's say you have an image of a house, you feed it to the network here, and then let's say you have the same house that is maybe squeezed or let's say rotated upside down, and you feel it to you this and then feed it to this image. Sorry, if you feed this image to this network, it's the same network, but you feed the image one time in the original position and one time in the augmented version, and then the network has to predict whether it's still the same object or not. And so that you train the network to recognize that this upside down house is indeed the same object. But let's say you give it something different, then let's say you give it a cat image here or something like that. Then you give a cat image to the network, and then it should predict that this is indeed different from the house. So you train the network to also better recognize objects. But here notice that you don't have the class labels or something. You just create the labels yourself by augmenting this. So if you augment this by rotating it, you know it's still the same house. So in that way you created this label for free without having a human to label this data, because you can do this all algorithmically. Of course, this is not the target task, you are probably interested in something else, but this is really useful for pre-training a network before you can find unit for your target dataset. It really helps to that you're making a network better. It's more like an advanced topic or something that is more recent. But if you are interested more in more details, there was a very beginner friendly article by Jeremy Howard, which you can find here, where you can learn a bit about self supervised learning. Another recent research trend is the focus on graph neural networks for graph data structures. So traditionally deploying was focused on text data and image data, and nowadays also people work with graph neural networks. If you have graph structured data, for example, like the structures of small molecules, and you can think of them as graphs where you have atoms connected by covalent bonds, you can think of it as a graph neural network. Like I found a nice introduction to graph neural networks here. If you're interested, there are so many papers, but I think this is an interesting beginner friendly introduction to the topic. So it's all kind of related to message posting also. So that would be another interesting thing. Also, a recent trend is the work on large scale language models. So it started like in 2018, where people trained models with 94 million parameters, and then they scaled up. You probably heard about GPT-2. It was, I think, in 2019. Now there's GPT-3 with 175 billion parameters, and also GPT-4. So language models become bigger and bigger and bigger. Of course, there are also some research approaches that focus on keeping things small, like distilled BERT. It's like a small version of BERT. So in that way, people also make smaller versions of existing models. But the trend is somehow going towards the bigger models. Of course, this is something that is really out of the reach of most academic researchers. This is something you would do at a big company. So anyway, here's also interesting or nice blog post summarizing the research highlights, focusing mostly on natural language processing. This is where I found this image, which I think is based on some other website. But this is also, if you are interested in these large scale language models, it would be an interesting read for you. We will be covering actually some of these models at the end when we talk about transformer models, because they are all based on transformer architecture. And another trend was transformers and vision, where people now also adopt these transformer architectures to computer vision. So however, this is also really large scale. So here, for example, they say even like an image net, like 40 million images is not enough to train a vision transformer. So it's really something that is mostly out of reach of academic research. And also these transformer models, they may work very well on very large data sets, like 500 million images or something. However, for most applications, convolutional neural networks will still outperform them. There was also recently just a new architecture of convolutional networks. So the convolutional networks are still status quo. It's still what you would use in practice for computer vision. So it's nothing like, it's very experimental. Nothing, not very close to being competitive with convolutional networks on common images. But I thought that it was interesting and worth mentioning where things are going.